Welcome back. Now we've exposed some properties to Blueprint, but we've only exposed them to the Details panel. This is great for changing values of these variables before the game starts, but if we want to change them at runtime, we have to change them here in the event graph. Now let's say we want to get the value of amplitude here in the event graph and change it, say in the tick function. Well, if I right-click and search for amplitude, I'm not going to find anything. That's because using the uProperty specifiers that we've learned so far only has to do with the Details panel. If we want to expose those variables to the event graph, we have to use different specifiers. Now, exposing to the event graph depends on whether we want read and or write access. If we only want to see the value but not be able to change it, we can do that. You see, uProperty can handle multiple inputs. We simply add a comma and add more specifiers. Now, to make amplitude visible but not changeable in the event graph, we use Blueprint read only. Now, Blueprint read only cannot be used on private variables. I'm going to show you what happens if we try to compile this. Now, to compile, I'm going to close out of the Unreal Engine editor first. And now I'm going to Control B to build my /module. Now it says 0 succeeded. And in the output, we see Blueprint read only should not be used on private members. So as I just said, we can't use this on a private member variable. We'd have to move it up to the protected section. So let's go ahead and move amplitude up to the protected section and now compile. I'm going to go ahead and Control F5. That way we'll launch the editor upon a successful compilation. So we see that we are succeeding compilation now. And I'm going to go ahead and click Open so we get that BP item blueprint back up. And if I right-click and search for amplitude this time, now we can see a getter for amplitude. We can click that and we see a amplitude node. So we're getting the value of amplitude. So that's cool. We can expose amplitude to the event graph now. But what about actually changing it? We can't type amplitude and get a setter. There is no set amplitude, so we're restricted. We can read, but we can't write to the value of amplitude. So if we want to be able to write to amplitude in the event graph, instead of Blueprint read only, we use Blueprint read write. So let's save this and go back and hot reload. And after hot reloading, we can go back into BP item and right-click and search for amplitude. Now we see not only get amplitude, but set amplitude as well. We can click that, and here's our setter for amplitude. So now we have a bit more access in Blueprint. Now, as I mentioned, we have a My Blueprint panel, which shows our variables down here. But we don't show those variables inherited from C++. To see those, we have to click the gear icon and check Show Inherited Variables. And now we see more information down here. Our variables are under Item. There's Amplitude. Now notice we're only seeing amplitude because that's the only variable that we've exposed using Blueprint read write. But we can expose other variables as well. So let's say we'd like to expose time constant. Now, in order to use Blueprint read write or Blueprint read only, it cannot be private. So we have to move it up to the protected section. So let's do that. And we'll go ahead and give time constant Blueprint read write. So we'll go ahead and save and hop back into the editor and hot reload. Okay, so after reloading, we'll go back to BP item and there's our time constant. So we can get it by searching for it here in the event graph itself. There's a get and set time constant, and we have it here under item. So let's say we'd like to set amplitude. Maybe we'd like to decrease its value steadily over time. We can simply hook this up to event tick and take amplitude and subtract a value from it. Let's subtract some value such as 0.05. We'll go ahead and hook this up. So we're subtracting 0.05 from amplitude every frame, but the thing is that's going to keep amplitude going down into the negative values, getting more and more negative. Its absolute value will keep getting bigger. So what we can do is clamp this value so it never goes below 0. So we can drag off and type clamp and choose clamp float. Now clamp float allows us to provide a minimum and a maximum value. And if the value we pass in is ever lower than the minimum, then clamp will return 0. And if it's ever above the maximum, clamp will return 1. But we can change minimum and maximum to any values we want. I'm just going to clamp this between 0 and 1 and set amplitude to the result of the clamp. So amplitude is going to keep decreasing. So this calculation is going to give us smaller and smaller values until we get to 0, at which point we'll never go below 0. Let's go ahead and hit play and see what that looks like. Now, 0.05 is kind of a lot to subtract from amplitude each frame. So what I'm going to do is multiply 0.05 by delta seconds. So let's get delta seconds out here, get ourselves a multiply node, and instead multiply delta time by 0.05. And now we'll subtract this value from amplitude instead. So we're taking amplitude, subtracting delta seconds times 0.05, and then taking the result of that and clamping it between 0 and 1, and resetting amplitude to the new value. So if we hit play, we're oscillating, but we should eventually see those oscillations dampen down to 0. This type of behavior is known as damped oscillation. It's when we're oscillating using the sine function, only those oscillations are getting smaller and smaller as amplitude continues to decrease. Kinda cool. So anyway, that's just an example of how we might want to change the value of one of our exposed variables here in the blueprint. Now notice that amplitude and time constant are in the item category. Same goes for the details panel for the blueprint itself here. We're under item. And if we keep adding more and more variables, they'll all just get piled up right here in item. But it'd be nice if we can organize them in their own categories. Otherwise, this would get out of hand the more variables we have. So let's hop back into Visual Studio, and we can give these categories by adding a new specifier. So we'll add a comma here, and this specifier is category. And we can set the category by creating the name of a new category. So for example, we can call this sine parameters. Now we can add sine parameters for the category for amplitude as well as time constant. So I'm going to paste that right here in the U property for time constant. Let's go ahead and hit save. Now if we hop back in the editor and hot reload, now if we hop back into the blueprint and click item BP self, our variables are not at the top anymore, but if we scroll down, we have sine parameters, and there's amplitude and time constant. And down here in variables, we have sine parameters down here at the bottom. We can expand that drop down, and there are our variables. So now we have a way to easily find the variables we're looking for. We just look for sine parameters. And if we right-click in the event graph and search for amplitude, we see that it's under the category sine parameters. In fact, we can search for sine parameters and see all the variables and each option we have for those because they're in that category. So this allows us to keep our variables organized. Now, I mentioned that we can't use blueprint read-write on private variables. Well, that's not entirely accurate. We actually can if we use an additional specifier. Let's say we'd like to expose running time to the event graph. Now, we shouldn't be able to change it, but maybe we'd like to access it and use its value somehow. Well, then we'd give it blueprint read only, right? But we can't do this unless we make running time a protected variable. Well, if we really wanted to expose it and keep it private in C++, we could do that. There's a very strange looking specifier. It's meta. And the syntax looks like this. We say meta equals, followed by a set of parentheses, and inside the parentheses here, we can place meta specifiers. Meta specifiers are sort of their own category of specifiers. So we could place a comma-separated list of inputs in this inner parentheses here. And the one that we would need in order to expose this private variable to the event graph is allow private access, and we have to place an equals followed by true in quotes. Wow, really weird, right? This is a strange syntax, but that's the syntax for meta specifiers. And that's how we would expose running time to the event graph, even though it's a private variable. So if we go ahead and save this, we can hop back and hot reload in the editor. And once we're done, we can go back to BP item and search for running time. And there it is. We can get running time, we can use it for its value, but we can't set it because it's blueprint read only. But if we really wanted to, we could make it blueprint read write, but I'm not going to do that for running time, as there's no need. So meta allow private access equals true is what we have to add to the U property to expose a variable that's private to the event graph. Great job. I'll see you soon.